All right, quiz review, Unit 4. So some formulas. Slope, y minus y over x minus x. Doesn't matter which direction you go as long as you go the same direction. Remember, yum-yums on the picnic table, y on top. Distance, square root, big old square root. That's just x minus x and y minus y. Be careful, this is why I say put the shell of the formula down first, then plug in the numbers, so that you don't make a mistake plugging in negative numbers here. You will get double negatives at times. And the mid-segment is not really a formula, it's just half of the side that is parallel, or half the parallel side. All right, parallel lines have slopes that are the same. Perpendicular, remember this is the symbol, and perpendicular, which looks like an upside down T, right, are opposite. And think about it, that just makes sense. So if I have a line going this way and this one's intersecting at a 90-degree angle, this one's positive and this one's negative. They have to be opposite. And they are reciprocal, which means flip the fraction. Find the slope between the following points, then find the parallel and perpendicular slopes. So I like to put a star next to the one I'm starting with. In this case, I'm going to have a double negative. That's okay. A minus negative 2. We're going this way. I have to do 9 minus 3. I cannot go back round robin and do 3 minus 9. When you do a double negative, subtract a negative, that becomes plus. So that's going to be 10 over 6. You can leave it 10 over 6. You can reduce it to 5/3. Either one will be acceptable. The parallel line will also be 5/3. And the perpendicular will be opposite and then flipped, negative 3/5. And it doesn't matter where you put the negative, top or bottom. All right, so I'm going to start with this one this time. Negative 7 minus negative 3. Y is on top. On the bottom, negative 2 minus 9. That's going to become plus. 3 minus 7, or negative 7 plus 3, is negative 4. Negative 2 minus 9 is negative 11. A negative divided by a negative is positive, 4 over 11. Parallel is going to be exactly the same. And then the perpendicular is going to be negative 11 over 4. I'm going to start with this one again, just to mix it up. 0 minus negative 4 over 2 minus 3. That becomes plus. That's 4 over negative 1. Now, you can just put negative 4, or you can put negative 4 over 1. Doesn't matter. This is going to be the same thing. And the perpendicular is going to be flipped 1/4 and positive. Okay? So remember, if you write it as a whole number, there's really a 1 on the bottom. So when you flip it, the 1 goes on top. Okay, on these, you don't have to bother doing the formula. You can just count. So line A, always check y first. So I can go from this dot and go up 1, up 2, up 2, right 1, right 1. So 2 over 1, or just simply 2. Now remember, if I can write my name on this, and it's going uphill, I have a positive slope. This one, consequently, is going to be a negative slope because my name is going downhill. Now, I go down 1, which is negative 1, and then I go right 1, 2, right 2, negative 1/2. Those are opposite and reciprocal. The 2 over 1 becomes 1 over 2, positive becomes negative, so that's perpendicular. Now I want to show you, you could have also gone up 1, which would have been positive 1, and then left 2, negative 2. Doesn't matter where the negative is. Okay, line A. Up one, right one, that's just one. Now this one, these are not going to be perpendicular because they're both positive. My name is going uphill on both of these. So on this one, I'm going up one. I'm going to use this one over here because this one doesn't exactly, well, it is on 3. The line's just very poor. And then I'm going to go up one, and I'm going to go right 1, 2, 3. Now those are not the same, but they're not opposite reciprocal, so it's neither. All right, line A is clearly negative. Look, going downhill. And this one's clearly positive. My name's going uphill. Slightly, but still uphill. So for line A, I'm going down 1, down 2, down 3. So down 3. And then I'm going right 1. I could have counted up 1, up 2, up 3, and then left 1. Notice they're both -3. And I can write either one of any of those ways. B. I'm going up 1, that's positive, and then on the bottom, right 1, right 2, right 3, 1/3. Line B is the same in 7 and 8. Exact same line. Now, 1/3, -3 over 1, opposite and reciprocal, perpendicular. All right, label the parts of the triangle. So this is a leg because they're the equal ones. This is the vertex angle, I'm going to abbreviate. This is the base angle, I'm going to abbreviate. This is the base side right here, or we can just call it the base. That's it. And remember, the base angles are also equal. Opposite sides, opposite angles equal. Okay. Solve for the suggested value. Notice these are same, which means that and that are the same. So I can just take 3x minus 5 equal 2x plus 20, and I can just do it right here. Now I like to keep my x's positive, so I'm going to subtract the 2x. 3x minus 2x is x, minus 5 equals 20. Then I'm going to add 5 and get x equals 25. Then it asks just for the legs on this one. So I'm going to plot 25 in right here. 2 times 25 is 50, plus 20 is 70. I could also put it right here. 3 times 25, 3/4 is 75 cents, minus 5 is 70. It works out either way because they are the same. So this triangle is isosceles. It doesn't ask for that, but never hurts to practice our vocab. All right, angle A and B. Well, this angle and this angle have to be equal. If I spend $180, I have $180 to spend, and I spend 42 at one store. I have to do 180 minus 42 to figure out how much I have left. I have $138 left. But I have to spend the same amount at this store and this store because they're equal. So I'm going to divide by 2. And that's going to give me 69 degrees. All right, this angle and this angle are equal. So right off the bat, we know this is 27 degrees. A and P are equal. Now, if I spend 27 at 2 stores, that's $54. How much did I spend at the third store? $180 minus 54. So $180 minus 54 is 126 degrees. I don't know what equation. Oh, I just did the work up there. Never mind. Sorry. All right, BCD is an isosceles triangle. So it says draw and label your triangle. So I'm going to put a triangle here. Now, to figure out what to label it, It says C is the vertex, so that's going to go right here. It's easier to put the vertex on the top. You don't have to. So that makes this B and that D. You could switch them. It doesn't matter. Those are going to be equal, and those are going to be equal. You just know that right off the bat. You can do that before you read anything else. Now, find x in the measure of each side. If BC is 2x plus 4, and BD is x plus 2, we don't need that right now. We're going to kind of hold that off to the side. And CD is just straight up 10. Well, the two sides, BC and CD, are equal. So I just say 2x plus 4 equals 10. Subtract 4. 2x is 6. Divide by 2. X is 3. Now, we already know what CD is. It's right there. It's given to us. And we don't actually have to plug in the 3 because we know this has to be equal to it. So BD, I just need to plug 3 in right here. 3 plus 2 is 5. And that's it. Oh, I left it blank. Which two sides are congruent? I said it, but didn't write it. BC and CD. For each triangle, find x and the missing side length, draw an angle figure. Same thing. So MKC is an equilateral triangle. Doesn't matter where you put the M in KC because everything's equal. So MK is 3x, KC is 2x plus 10, and MC is x plus 20. You can do any of these, and it's going to be pretty much the same amount of work and pretty easy. So I'm going to do 3x equals x plus 20. I'm going to subtract x. It's going to give me 2x equals 20. And when I divide by 2, x is going to be 10. And when I plug the 10 in, it doesn't matter which side I plug it into because they're all equal. I get 30. 10 plus 20. All right, RSC is an isosceles triangle. Too far. It says nothing about the vertex angle. So we got to look and see which sides are the same. It says RS, RC are equal. So R, that's a B, RS is equal to RC. Now RS is 5x plus 3. And I just put that in the wrong spot. Doesn't matter because they're equal. But, just to be specific, RC is 7x minus 5. Now at this point, we don't really care about this, 3x minus 1. We can label it now, it doesn't matter. Because what we're doing is we're setting these two equal to each other. 5x plus 3 equals 7x minus 5. I'm going to move my variables to the right because I want to keep my variables positive. So I'm going to do minus 5x. That's 5, believe me. So I get 3 equals 2x minus 5. Add 5 to both sides. 5 plus 3 is 8. And then when I divide by 2, x is 4. Now, this matters. I'm going to plug 4 in right here. 4 times 3 is 12. Minus 1 is 11. Notice they did not ask for the 2 legs, but if they did, I'd just plug it in here, and I get 23. Whether I plug it in here or here. 20 plus 3, 28 minus 5. Same answer. All right. So, 103 degrees. As soon as I see that, I know that's an obtuse angle. So, obtuse goes on the angle line. There are no obtuse sides. Now, in this drawing, you can see that this side, and this side are all different, so it's scalene. There are no markings, but you know they're different. All right, this one, angle, less than 90, so that's a cute little angle. And since these two angles are equal, these two sides are equal, which makes it isosceles. And this one, being a right angle, this is the hypotenuse. The hypotenuse is the longest side. So one, it's not marked the same as the other two, and mathematically it has to be longer than the other two sides. So therefore, this tells you it's a right triangle, so there's a right angle, and it's isosceles. I know that's not how to pronounce it, but I just like saying it that way. Okay, distance formula. Now remember, this is good practice. Whoopsie. So, I say start off every time like so. Do this first. Now plug your numbers in. So UF. So I'm going this way. So it doesn't matter which way I go, but I'm using those 2 points. So let's say it goes the way I just drew. That's fine. -3 minus 4. It avoids the double negative. So if I went -3 minus 4 for my x's, I need to do 7 minus 5 for my y's. Now, this is -7 squared. Put in parentheses or just put 7 squared because it's going to end up being positive anyway. -7 squared is the same as 7 squared. So if you want to just write 7 squared as a cheat, it's better than getting -49. Because when you type it in the calculator and it tells you -49, you should know better than to write that. Then 7 minus 5 is 2 squared. And that's going to be 49 plus 4. All right? And so you can put the square root of 53, or I will also accept if you want to put it as a decimal, but you can leave it right there. You don't have to go the extra step. You can put 7.28 or just 7.3. Now we're going to do it for UN. Again, just draw this. Now fill in your numbers. UN. So we're using these two. So I'm going to go -3 minus 1, x minus x, and then for my y, 7 minus -5. Notice I have a double negative there. So that gives me -3 minus 1 is -4 squared. That's the same as 4 squared. Plus 4 plus 5. No, sorry, my bad. That's a 7. I just double checked my writing. We're doing UN. So 7 plus 5 is 12 squared. So that's going to be 16 plus 144. So that is the square root of 160. That's over here. Okay? But you don't want to leave this one because the square root of 160, well, I guess you could, is going to be 12 point, it says 649. So you can just do 6, or if you do 6.5, just make sure you round it correctly. I was thinking 1600 for a second. That would have been 40, but sorry. All right, one last one. Good practice. And the best way to get this down is just to practice it. Like start over, like cross it out and just cover it up and start over with another one. Do it over and over again until you get used to it. FN. So we're doing this one and this one. So 4 minus 1, go the same direction. 5 minus -5. Which is going to become 5 plus 5. This gives me 3 squared plus 10 squared. That's 109. And if you use the square root of 109, you get 10.44. Approximately. All three sides are different, so that's scalene. Again, the best way to get this down is just to practice it over and over. Okay, in each triangle, points R, S, and T are midpoints. Name the 3 mid-segments. Just the small triangle. RS, ST, and RT, or TR. It doesn't matter which way you go. Complete the statement. RS, we talked about this in class, RS, I meant to change that to green, right there, that is parallel to AC. All right? Then we have ST. ST is right here. That is parallel to, remember, just take your pencil and roll it down, BA. And then BC, oh, that's a tricky one. That's the whole line right here, not the mid-segment. So what is that parallel to? Now we're going from the big one to the small one, RT. And technically, these should all have lines above them, line segments. Okay, if RS is 14, all right, then what's AC? So RS, again, is right here. It's a small piece. AC is the big piece. It's double, so that means it's going to be 28. BC is 26. Where's BC? Well, BC, whoops. BC is the big one. So RT is going to be half of that. I know how to use a smart board. 13. And BA. If BA, where's that? BA is this big one right here, is 30. Then BR, ooh, that's a tricky one. BR is going to be half of that because R is the midpoint. So if this whole BA is 30, then these two pieces are equal, which makes it 15. And RA would also be 15. And that's all.